So let's see on how we can be able to complete the square of the quadratic expressions. But before we go further with the completing square of the quadratic expressions, I would like you to understand about the discriminant. Let's say we have the quadratic expression. Let's say it should be given as ax squared plus bx and plus c. Now, what is a discriminant? Discriminant, this is the expression that expresses the relationship that exists among the values of a, b, as well as the c. And it is symbolized as capital D. And the formula is given as b squared minus 4ac. So that's how we calculate the discriminant, where b, a, as well as the c are obtained from the same actually quadratic expression. And the discriminant can be positive or negative. Let's say we have the quadratic expression given as, let's say, 2x, actually x squared minus 2x, and let's say plus 1. What is the discriminant of this quadratic expression? We know that a is given as 1, and b is given negative 2, and c is given as 1. Now the discriminant, which is b squared minus 4ac, we'll have it as negative 2 to the power 2 minus 4 times 1, and times 1 as well, which means we'll have it as 4 minus 4. That is given as 0. That is the value of the discriminant for this quadratic expression. And let's say we have 4x squared minus 2x, let's say plus 5. What is the discriminant of this actually? What is the discriminant of this actually quadratic expression? We have a that is given as, let's say, a 4, and we have b that is given as negative 2, and let's say we have c that is given as 5. Now the discriminant, which is d, b squared that is negative 2 to the power 2 minus 4 times 5 and the times 4. In this case we have it as 4, and we have it as, should be negative 80, like that. So that would be given as negative 76. So this is the value of the discriminant you should have to understand. And let's say we have x squared minus 2. Now this is also a typical quadratic expression. What is the value of the discriminant? We have a is given as 1, and b is given as 0, and c is given as negative 2. C is given as negative 2, then the discriminant is given as 0 to the power 2 minus 4, a that is 1, and c that is negative 2. The discriminant will be given as 0 plus 8. Therefore, the discriminant is given as 8. So that is the value of the discriminant. And likewise, let's say we have x squared, and let's say minus 7x in that way. What is the discriminant of this quadratic expression? We have a being given as 1, and b is given negative 7, and c is given as 0. Then the discriminant, what would be that? Try to get it that and up to. Let's say we have the quadratic expression given as x squared minus, let's say, mx, and that should be plus 4. Assuming that the discriminant of this actually quadratic expression is given as, let's say, 2, what is the value of m? Now in this case, a is given as 1, and the b is given as negative m, and the c is given as 4. We know that the discriminant is given as b squared minus 4ac in that way. Now we have it as being given as 2 is equal to b squared minus 4ac, because we have been given. Then now let's think of substituting. Have 2 is equal to b, that is negative m to the power 2 is given as m square minus 4a, that is given as 1, and c is given as 4. So in this case we'll have it as 2 is equal to, should be m square and then minus 16. That will be given as m square is equal to, should be 18. Therefore m will be given as the square of plus or minus 18. So that's how we should have to solve for actually m in that case. So which means we'll have it as m is equal to, by the way, you should have to understand that we are going to introduce square both sides in that way. So m is given as plus square of 18, of course plus is silent, then you have m is equal to negative square of 18. Of course, using the sides we'll have it as 3 square of, should be 3, no, should be 2. You have negative 3 square of 2. So those are the values of m you should know. Let's say we have, should be mx squared minus, let's say 2x plus, let's say 4. Given that this is the quadratic expression with a discriminant given as, let's say, negative 5, find the value of m. And let's say we have x squared minus 4x plus, let's say, d. Given that the discriminant of this quadratic expression is given as, let's say, should be 14, find the value of d in that way. So keep that in mind. So now, how can we actually compute the square of the quadratic expression? Let's say we have the quadratic expression given as ax squared plus bx plus c. Now, how should we have to compute the square of the quadratic expression? Provided the value of a is given as 1, then the expression that is possessing the computing square of this quadratic expression is given as x plus h to the power 2, rather should be x minus, but anyway should be x plus h to the power 2, but let's have minus here, should be x minus h to the power 2 plus k. So this is the form in which this is actually a quadratic expression should be expressed as to be. So this is how we actually compute the square of the quadratic expression. Mind you, this is being expressed from the fact that actually the value of a is given as 1. And guess what? The discriminant of this expression, it is given as 0. Hence b squared minus 4ac is equal to 0. That is for this expression. So keep that in mind, that the discriminant for this expression, it is actually given as 0. And also from the fact that the value of a is given as 1. So now, using this actual discriminant, and from the fact that the value of a is actually given as 1, let's think of solving for c in this actual equation. In this case, we'll have it as b squared minus 4a, that is 1 times c, which is given as actually is equal to 0. We have b squared minus 4c, that will be given as 0. At the end of the day, we'll have negative 4c being given as the negative b squared. Then we have c being given as b squared over 4. That is the same as b squared divided by 2 to the power 2 using the laws of indices. That is the same as b over 2 to the power actually 2. So that is the formula we can use to solve for c in case it is necessary. And you'll see how best c will be actually important in completing the square of the actually quadratic expressions. But keep in mind that we can be able to complete the quadratic expression, to complete the square of the quadratic expression, upon having this expression to be in this form, provided the value of a is given as 1. Then on the same case, the discriminant of this expression is given as 0. And since we have a condition of having a is equal to 1, if we substitute here and solve for c, we'll have this one as this. So we're going to make use of this in the process of making this one to be in this form. Keep it cool. Let's say we have to complete the square of the following quadratic expressions. Let's say we have x squared and plus, let's say, a 6x, and let's say plus 3. Now complete the square of this quadratic expression. So how should you go about it? Now first thing, ensure that the value of a is given as 1. As it stands here, it is okay. The next, just have to highlight the value of b. What is the b? We have it as a positive 6. Then we should have to introduce the c into the actual expression despite this one. So in that case, we'll have it as x squared plus 6x and plus c plus 3 and the minus c. At the end of the day, you should have to understand that having, let's say, m minus n, it is the same as, let's say, negative x squared and plus, let's say, m and plus x squared minus n. Nothing changes here, because if you go for the like terms, we'll have negative x squared plus x squared will be given as that will be the same as that. And using that principle, having positive c and negative c here, nothing changes, because at the end of the day, having this expression, it is the same as that expression. So keep that, and always you should have to introduce the positive c here, and here should be the negative c as it stands there. And I should have to understand that we should have to group them. Here should be that, and also here should be this. Now, how should you solve for c? The c is given as the formula b over 2 to the power 2. And what is the b? We have it as 6. Divide by 2 over the power 2. That will be given as the 9. So which means we should have it as 9. So we'll have x squared and the plus 6x plus 9, like that, and plus 3 minus 9. And on the same case, we should have to express this to have the power of 2. Mind you, whatever the case, the value we calculate from here, it is given as the perfect square. So we should have to express 9 to have the power of 2. So which means we'll have it as x squared plus 6x and the plus 3 to the power 2, and like that, and minus, we'll have 6. Then on the same case, we should ignore the middle part, and we should have to give each sign to actually this one. So in this case, we'll have it as x squared and the plus 3 to the power 2. Since it is positive, then this one also will also be just positive. Of course, the impact won't necessarily be observed because this is also a positive. But if we could have here a negative, it means we could have had negative there as well, using the same principle. And the minus 6 like that. And in this case, since actually we ignored the middle part here, then whatever we do here will be true. We'll have x plus 3 to the power 2 minus 6. Now this is happening because we ignored the middle actually part here. Otherwise, actually, generally speaking, if we have, let's say, x to the power 2 minus, let's say, 2 to the power 2. This is not the same as x minus 2 to the power 2. It's something different. Even if we have, let's say, m minus 2 to the power 2, this is not the same as m to the power 2 minus 2 to the power 2. It is different. But we are doing that because we are able to have this as this because we ignored the middle part here. It is only acceptable there. So in this case, this is how it should be. That's how we complete the square of this quadratic, of the quadratic expression that we had in that to this form. So keep that in mind. And also, what if we have this case? Let's say we have x squared plus, let's say, plus 7x, and let's say minus 9. Now, how should you have this one up to? First thing, we should have to ensure that the value of a is given as 1 as it stands here. Then we should have to highlight the value of b only, that is 7. Then I'll have it as x squared plus 7x and the plus c minus 9 and the minus c. And we should have to group them in this way. Now for this case, we'll have the value of c that is given as 7 divided by 2 over the power 2. That will be given as 49 divided by 4. Now have it as x squared plus 7x and plus 49 over 4, like that. Then we have it as negative 9 minus 49 over 4. That will be given as that. And the next we'll have to simplify. And also in the same case, we should know the middle part and giving the sign of the middle part to this. And also in the same case, we should have to express this to have part 2. In this case, we'll have it as x squared plus, should be 7 to the power 2 divided by 2 to the power 2, like that. And we should also have to simplify this one as well. We should have to express that one as the single fraction. We have negative 9, negative 49 over, let's say, 4, like that. I have 4 here, negative, we have 49, we have negative 36. Negative 36 should be negative 36. Let me just have that here. We have 49. That is, should be 15, keeping 1, you have 85. So which means we'll have it as negative 85 divided by 4. That will be given as that. So that's how we complete the square of the quadratic expressions. In this case, we'll have it as x and the plus 7 over 2 and the over to the power 2 minus 85 over 4. Of course, it is the same as multiplying everything by 4. We'll have it as 4x plus 7 over 2 to the power 2 minus 85. It is the same as this. So take note of that. Now, how about if we have, let's say, 2x squared plus, let's say, 6x and the minus 12. How should we complete the square of this quadratic expression? Now, principle remains the same. Now, from the fact that the coefficient of x squared, which is a, is no longer 1, we'll have to make sure that it is given as 1. We'll actually divide everything by the value of 2, by 2. So we'll have it as x squared plus 3x and the minus, and that should be 6. Now you can be able to complete the square of that expression on your own. And let's say we have negative x squared the plus, let's say 6x plus 7. So in this case we'll have to divide everything by -1 to make sure that it is positive. So we'll have x squared minus 6x minus 7. So you can complete the square of that one. And how about, let's say we have this. Let's say we have 2 over, let's say 7 x squared minus, let's say 5 over, let's say 2x, and the plus 1 over, let's say 3. Now how should you complete the square of this expression? So now first thing, we may think of eliminating all actually denominators. So we'll multiply everything by 7. That will be given as 2x squared minus 35 over 2x and the plus 7 over 3. Then we'll multiply everything by 2. That will be given as 4x squared minus 35x and the plus 14 over 3. Now this is okay, and of which you can also think of multiplying everything by 3. That will be given as 12x squared and minus, what is 35 times 3? It is given as 100. 1 is of 5. X plus should be 14. Then we'll have to divide everything by 12 to make sure that the value of a is given as 1. Then you'll be able to complete the square of actually a third one. So that's how we complete the square of the quadratic expressions using the concept of the discriminant. So thank you for being there, but don't forget to subscribe. It should be Analytical School of Science. Thank you.